Alright, number 9. This is a question that I actually kind of really like. I like ones like these. So it's asking us correctly fill in the blanks using the word all, some, or no. And in the cases of some or no, I'll go ahead and draw pictures because I might ask you to do that too. If I say like, if it's not true, draw a picture that shows it's not true. Just because I think that's a good intuition to have for one, my favorite word. And it can be really helpful to give examples of why things aren't true, and it can really stick in your mind if you have an example in your mind. So we want to correctly fill in the blank, all, some, or no. So first, blank rectangles or kites. What's the case for that? The answer is some. You could have a square which is a kite. That would be perfectly acceptable because if I took, say this is a pair of corresponding sides, this is a pair of not corresponding, pair of adjacent sides, that is a pair of adjacent sides, the definition of a kite would be fulfilled. But if I had a long rectangle like this is definitely not a kite. No matter which adjacent sides I pick, it doesn't work. I've got a long side and a short side. So I get some rectangles or kites. Blank right triangles are equilateral. So the answer is no right triangles are equilateral. Why is that? We talked about this a little bit in class. If your equilateral triangle, and this is the only shape that does this, then all of your angles have to be 60 degrees. There's no moving around whatsoever. So if all of your angles are 60 degrees, you definitely can't have a 90-degree angle. Blank right triangles are scalene. The answer again here is some. So you could have a triangle like this. This would be an example of one which is not scalene, or which is scalene, where the tick marks go like this. But you could have a isosceles right triangle, like that one. And we know one like this exists. We could use Pythagorean theorem and come up with one. Its side length could be 1 square root of 2, and that would be perfectly acceptable. It satisfies triangle inequality, all of that good stuff. So some right triangles are scalene. Part D, blank parallelogram have two pairs of parallel sides. The answer to that one is all, and that's in the definition, parallelogram. So all parallelograms have that. Part E, parallelograms have all sides congruent. The answer to that is a nice healthy sum. An example of one that would work is our friend the rhombus. This rhombus would be an example that has every single side congruent. But I could do the same thing I did for the rectangle. Take a really long parallelogram. Or actually, if I even wanted, I could use the exact same examples from A. I could use the rectangles because rectangles and squares are in particular rectangles, or are parallelograms, and squares are rhombuses. But this works out for that. And then finally, blank quadrilaterals have sum of interior angles 360 degrees. The answer to this one is all. And you could use that by thinking that there's two triangles. You could use the formula. Either way, you're going to get all quadrilaterals have 360 degrees.